All right, so I'm going to kind of review the first lesson so that those of you who are absent or having some technology difficulties, you can kind of review what we talked about in class as far as notes. So we're starting off with a review of physical setting. If you had Mr. Miller, you should be really familiar with all this, and it really is nothing more than a review. But some of you guys may have had it a while ago. And then at the end of the year, with when we ended it early, you didn't get as much experience as you normally would have. So here's a little review of, we're going to start off with a scientific notation. So if you remember, when we're doing scientific notation, we're going to take a large number in this case, and we're going to make it into a smaller number, easier to handle. Now this number is not 3,960,000 is not a huge number. You could write that pretty easily, but when we're dealing with chemistry, a lot of times we're dealing with numbers that are very, very large. So scientific notation is what we'd use to write these numbers down. In a few minutes, we're going to be talking about significant figures, and those also play into sometimes choosing to use scientific notation. So remember, when you're changing a number from this long form to scientific notation, then you're going to be basically moving the decimal place. So in this example here, our decimal is here, even though it's not written. In order to get it between a number between 1 and 10, we're going to move that decimal place, and we're going to move it 1, 2, 3, 4, 5, 6 places, which means our number is going to be 3.96. We moved it 6 places, so our exponent's going to be 6. If a number is big, we're moving it to the left. Now let's look at the other side. If a number is small, smaller than 1, we're going to take our decimal point and move it 1, 2, 3, 4, again turning it into a number between 1 and 10, 7.2. And because we moved it 4 spaces, we're going to write the exponent as a negative number, because this number is much smaller than 1. We'll be actually using numbers that are very, very much smaller than 1 when we're in our chemistry class. So I'm going to work through some examples. If you're watching this video and you know what to do, go ahead and you can fast forward and just look at the answers. When a number is already in scientific notation, I'm going to just expand it out into the long form. So here we go. So we've got this number 64200. Our decimal point is here. So I'd need to move it 1, 2, 3, 4. And this number would become 6.42. I'm going to leave the zeros off, times 10 to the fourth. The next example, we've got a number that's less than 1, so I'm going to be moving my decimal point in this direction, 1, 2, 3, 4, 5, and this becomes 3.2 times 10 to the negative 5, because I moved it to the right. Our next number, 1, 2, 3, 4, whoop, I went too far, back up. 1, 2, 3, there we go. 9.01 times 10. Again, I had to move it that direction, so it's going to be to the negative 3. The next example, our decimal point is here, 1, 2, 4.5 times 10 to the second. Now I'm going to expand this one back out. Our decimal point is here. We have a positive exponent, so my decimal point is going to move in this direction, and it's going to move 3 spaces. So 9, 9, 8, 1, 2, 3. Back up here. Our exponent is a negative number, so I'm going to be moving it in this direction. 1, 2, 3. You can kind of imagine zeros there, and that's going to give me 0.0091 when I expand that out. Here we've got a positive exponent, so my decimal point's going to move in this direction, and this is going to be 693. A negative exponent, so my decimal point's going to move in that direction. 1, 2, 3, 4, 5, 6, and now I'm ready to write the number 2721. Really, really tiny number. This one here, positive exponent, so I'm going to move it in this direction. 8420. Now there's 4 places I have to do, so I have to put another 0 here. And the last one, We've got a negative exponent, so I'm going to move my decimal point that way, and that's going to give me 0.00415. If you're having trouble with this concept, you can look up lots of videos on YouTube for how to do scientific notation. All right, so now let's talk about significant figures. And in class, we saw the video that's accuracy and precision. Basically, you're only as strong as your weakest link. If a scientist is very careful throughout an experiment but decides to guess on the final measurement, the results are no longer precise, and that must be communicated. So when we're looking at a chemistry problem, well, the reason why we use these things called significant figures is because it really does reflect back to what were we using to measure everything, or how precise could we be. Remember that accuracy is being close to the actual number that is the true value. And precision means getting something, the same results over and over again. So in our everyday language, we tend to use these both as meaning the same. But in science, accurate means you're very close, you're right on top of the correct value. And whatever measuring device you're using, that's going to give you more and more and more accuracy. If you get the same number over and over and over again, that means that you're very precise in your measurements. Accuracy is going to be completely depending on what you're using to measure. Let's take a look at some measuring devices. So when you're taking measurements, this is something that students just forget to do over and over again. And it's funny in class because I have people underline this, put a circle around it, and yet when I ask people to measure things, they immediately forget to do that. So let's do some practice here. It says, what increments did the device to the right count by if a scientist recorded the measurement of 11 milliliters? Well, if each one of these marks is 10 milliliters, there's 20, here's 30, here's 40, that line right there, the fluid line, would give you about 11. What increments did the device to the left count by if the scientist recorded the measurement of 110 milliliters? Well, then these lines must be going up by 100. Whoops, it's supposed to be 300 and 400. So when we're looking at these two beakers, which one is going to give you a more precise measurement? Well, this one is going up by tens. That's a fairly small amount. This one, each line is going up by 100. That's a pretty large amount. So when we're looking for which one is more accurate, this one here is going to give you a measurement that goes to the ones place. This one here is going to give you a measurement that only goes to the tens place. When we're thinking about significant figures, we're looking at how good of a measuring device did you have. Let's take a look at these rulers here. It says, record the proper measurements according to each of the centimeter rulers shown. So these are all in centimeters. Now, let's take a look at this first measuring one. So the green line goes to 5. So I think we would all agree that 5 is that first number. We have to estimate one place past what we can read. So I'm going to say that this is 5.0. I think that green line comes right to 5.0. You can see that we're in the ones place. I've got to estimate to the tenths. Let's look at another example. I've got a different ruler here with more lines on it. So when I'm measuring that green line, it's going to be 5 point. Well, I can clearly see that it's not to the 0.1 part, because these, of course, would be in tenths. So I would say this is 5 point, maybe 0, 1. Or I could say it's 5.00 if I wanted to say it's actually it. This ruler here is measuring in tenths. This ruler here is measuring in ones. Let's take a look at the ruler down below. Now, when I'm using this ruler, it's measuring in tens. So when I look at this, I have to really estimate where this line is. I'm going to say again that it's 5, but that's where my estimate is. I'm estimating in the ones place. when you're doing measurements, and this is really difficult for students to grasp, that you're going to estimate based on your measuring device. And we'll do some more practice with this. But the thing to remember is look at the scale of whatever you're using to measure with. And you're going to estimate 1 degree more accurate than what your measuring device is. Because you can use your eye, you can use your mind to determine whether it's just past a line or not quite to the line. And that counts for something. Just looking at where it meets the line on the measuring device you have for science is not quite good enough. You've got to go ahead and estimate 1 digit past the smallest increment shown. So in this one here, we had 1 is the smallest increment shown. So I have to record my measurement to the tenths. This ruler here is showing it to the tenths. So I've got to record my measurement to the hundredths. This ruler here, it's measuring to the tens. So I have to record my results to the ones. Hopefully that makes some sense for you. Let's go ahead and I'm going to just pause this for a second. All right, so now we're going to talk a little bit about counting significant figures. Remember, significant figures is what we get when we're reading something off a measuring device. So you don't have a complete description of what measuring device is used when we're doing a lot of chemistry numbers, but you can kind of tell what device was used based on the amount of significant figures. So there's lots of rules. Some of you may have, depending on what school you went to, you may have had a big list of rules to memorize: captive zeros, trailing zeros, leading zeros. Well, this puts it in a nice little flow chart. The first question you ask yourself is, does the number have a decimal place? If no, then you're going to find the first non-zero number and you're going to count to the last non-zero. Basically, you count until you run out. If your number has a decimal place, you're going to go from left to right, find the first non-zero, and count all the way to the end. So this is the other diagram that you probably remember better. Let me just make this bigger. And that we call this the Atlantic Pacific rule. And what you do is you pretend your number is in the middle of this picture. So let's take this number, 3.0800. And you ask yourself, is the decimal absent or present? If it's present for Pacific, you're going to start from this side. And as soon as you hit your first non-zero number, you're going to count till you run out. So this would be 1, 2, 3, 4, 5. It doesn't matter if they're zeros. It doesn't matter if they're not zeros. Once you start counting, you count till you run out. So this number here would have 5 significant figures. Let's do number 2. You ask yourself, is the decimal absent or present? In this number, it's obviously present. So I'm going to start from the Pacific side, go this way, count my first non-zero number, 1, 2, 3, and that would have 3 significant figures. Even if it's scientific notation, we're going to follow the same rule. Is the decimal absent or present? It's present. So I'm going to start from this side, 1, 2, 3. When you're doing scientific notation, you never ever count the times 10 to whatever exponent it is. So this would have 3 significant figures. Number 4 has the other example. The decimal is absent, so we're going to start from the opposite side, the Atlantic side. And we're going to go from this way till we hit our first non-zero number, 1, 2, 3. And again, I'm going to count until I run out. This would have 3 significant figures. Number 5, decimal's present. Start from this side, hit my first non-zero number, 1, 2, 3, 4. Number 6, again, I've got a scientific notation. Still ask myself the same question. Decimal absent or present? It's present. Start from this side. 1, 2, 3, 4. Number 7, decimal absent or present? It's absent, so I'm going to start from this side. First non-zero number. 1, 2. Count till I run out. Here's another number. Decimal absent or present? It's absent. So I'm going to go all the way over to here. First non-zero number is 5. So 1, 2. Number 9, decimal absent or present? It's present. So I'm going to go to this side till I hit my non-zero number. 1, 2, 3. And the last one, decimal absent or present, it's present. So I'm going to go until I hit my first non-zero number, which is the 8, count till I run out. 1, 2, 3. This would have 3 significant figures also. All right, now that we know how to count significant figures, we're going to move on to the rules for using significant figures in calculations. There are 2 different rules, and students tend to get very focused on the multiplication and division rule and forget completely that there's a different rule for addition and subtraction. So when you're doing a bunch of problems, you need to break these down and use the right rule for significant figures for each problem. We're not going to do too many problems that are super complicated where you have to do multiple steps of addition, subtraction, and so on. Most of our problems will be multiplication and division. And so I think that's where most students get kind of focused on, hey, we always seem to be doing this one, so they just follow that rule alone. And then when a new rule or a new problem is thrown in and all you're doing is subtracting or adding, you forget this rule. So the 2 different rules are, let me just back this up so I can get the scribble. There we go. 2 different rules are if you're doing multiplication and division, this is where you're going to need to count the number of significant figures. For addition and subtraction, you're going to record your answer to the least precise place value. And I'll demonstrate that in just a few minutes. Let's do some multiplication. The same rule would be true for division. What I like to do for these, especially if you're first starting, the first thing it's good to do is just count the number of significant figures in the numbers that you're going to be dealing with. This one has 2 significant figures because the decimal's present. This one has 2 significant figures, and this one has 2 significant figures. So you're going to need to have 2 significant figures in your answer. When you put this in the calculator, you get 12. You need to double check and make sure that your answer has the right number of significant figures. Well, 12, decimals absent, has 1, 2 significant figures, and so you're good. The number 12 is fine. Let's take a look at the next example. This has 2 significant figures. This has 1 significant figure, and this one has 3. Well, because this number here only has 1 significant figure, I'm going to need to round my answer to 1 significant figure. So when I put that in the calculator, I get 12. Now, rounding rules, if you're remembering back to probably elementary school, if you have a number that's greater than 5, the number is going to round up. If you have a number that's less than 5, the number rounds down. So if you look at the first number here, we've got 1, and it's followed by a 2. Well, 2 is less than 5, so you're going to round this number down. This will equal 10, because I'm going to go to the next lowest rounded figure. So there's 10. Let's take a look at the next example. I've got 200, which has 1 significant figure, and 30.0, which has 3 significant figures. So my answer is going to need 1 significant figure because this has the lowest number of significant figures. When you put it in the calculator, you get 6,000. 6,000 has 1 significant figure, so you're good to go. Let's look at the next example. Now some of these can be kind of tricky. It's never a typo. If there's a period at the end, that's a decimal point. So when you're counting this, decimal is present. So this would have 3. This one here would have 3. You put that in the calculator and you've got 6,000 again. But the thing is you need to have 3 significant figures shown, and when you write 6,000, it's only got 1. This is where you're going to need to use scientific notation. I can turn 6,000 into a number that has 3 significant figures. When I do that, I'm going to turn it so it's 6.00 times 10 to the third, because I moved that decimal place 3 spots. 1, 2, 3. I dropped off this 0, so I had the right number of significant figures. Decimals present, 1, 2, 3, and now I have the 3 significant figures that I need. Let's take a look at the next example. It's kind of the same sort of thing. 200 times 300, 3 significant figures, and 3 significant figures. So our next example is the next one. If I can get my thing to work here. There we go. This one has a lower number of significant figures, so when I put it in the calculator, 0.40 times 10.0, and you're going to get 4. But I have to have 2 significant figures. So in this case, I'm going to put 4.0. So I can add that 0 in so that it has the right number of significant figures. This one has 2 significant figures. This one has 1 significant figure. When I put it in the calculator, I get 0.070 times 100, and my answer is 7. Again, I need to have 2 significant figures, so I'm going to put an X. Sorry, it needs 1 significant figure, so actually I'm good on that one. Oop, not looking at my numbers. There you go, I'm fine with that. 1 significant figure, 7 has 1 significant figure. So that's how you do multiplication, and division would be the same thing. You're going to count your significant figures, and then you're going to round your answer or turn your answer into that number of significant figures. Let's try addition and subtraction, and that actually ends up being the one that most people forget how to do. All right, so for addition and subtraction, you're going to round your answer to the least precise place value. So let's take a look at these numbers. We've got 1.1, so that has a number that's in the tenths spot. We've got 2, which has no decimal at all. And we have 2.00, which has numbers in the hundredths place. So what we're going to do is we're going to round our answer to the ones, because that's the least precise place. So when we put these numbers in the calculator, 1.1 plus 2 plus 2.00, you're going to get an answer of 5.1, but we want to have it with only 1 or no decimal places because of that number there. So this is going to become just 5. The next example, we've got a number in the hundreds place, we've got a number in the hundreds place, so both of them are going to be the same. When we add these together, 0.01 plus 2.00, or sorry, 11, can't talk and type, and you're going to get an answer of 2.12. Let me do this so it's a little bit neater. There you go, 2.12. And that answer is going to be fine because I have my numbers to the hundredths place. Let's do a subtraction one. Here we've got one with a digit in the tens place and then a digit in the hundredths place. So our answer is going to be to the tens. So we've got 4.0 plus 2.00 equals 6.00. But we want to have it to only 1 decimal place, so it's going to, and the answer is going to end up being 6.0. Let's do the next one. We have 1 decimal place, we have 1 decimal place, but when we add it together, we get 0.9 plus 9.1, and that gives you 10. But we need to have 1 decimal place, so this is going to become 10.0. The next answer is going to be, actually I'll pause this so you have a chance to do yours, and I'll just write down the answers and see what you get. So when you put this in the calculator, you get 0.19, but you need to have 1 decimal place. We can't just leave 0.19. So I'm going to look at, this is where I'm going to need to round to. I look at the number that's behind it. 9 is more than 5, so this is going to round up, and 0.2 would be your final answer with the right number of significant figures. So when you're doing addition and subtraction, you're also going to round, if you need to, get to the significant figure. And this last one, well, again, I'll pause it and then I'll explain it. So when you add 4 to 96, you get 100. There is a point here, so I would want to keep the point right there. This has no decimal places. This has 1 decimal place, but because there is a point here, I would keep it. So that would give me a correct answer of 100 with a decimal point there. When you count that, that's going to give you the right number of significant figures. This is as far as we got on day one. We looked at scientific notation, which I included a short video on, and then for most classes, we finished the addition and subtraction, and then you have your homework. Remember, I did post the answers to the homework so that you could kind of look at a video and kind of walk through the answers and see an explanation in case you weren't sure about why your answer might be different than mine. We'll see you tomorrow.